Okay, hello everyone. My name is Hwaran Lee from Sogang University, and thank you for having me today. So, unlikely compared to the previous session, I will introduce a little bit more technical things uh, related to gender, but the topic is more inclusive rather than just gender. So as you can see, the title, my topic and the title of this talk is Evaluation LLMs with Socio-Cultural Awareness. So in the term socio-culture thing includes gender, but it includes the more things. So I will let you introduce. Uh, so I will start my talk with multilingual LLMs. So I believe that you are very aware of GPT-4 or ChatGPTs or Gemini and other things. So yesterday or the day before yesterday, OpenAI also released the new open model. So its name is GPT dash OSS, right? So anyway, so I want to underscore that the status quo of current LLMs are mostly English centered. So GPT-4, Claude, Gemini, or even open sourced LLMs are mostly English centered. However, you know that only under 20% are English speaker. Even includes L1 and L2. So L2 means like second language learners like me. So I can speak, my mother tongue is Korean language, but I have learned English and I'm talking in English. But so such people like me are included the 18.8% people. And there are more than 7,000 languages in the world. So that means there are still many unexplored languages. And as you can see this map, even one language such as English languages, English language is used in multiple countries. Like it is also used in Canada or Australia and Singapore. And they all the English languages in other different countries have a little bit different nuance or dictionaries, right? So here, how can we build such LLMs which can speak multiple languages? So I categorized the technical way could be in two approaches. The first one is specialized LLMs for specific languages from scratch. So like, for example, in Korea, I could say, so Hyperclover X, which from Naver, which is my X company. So I a little bit from it. Okay, so Hyperclover X or some Exxon LM model from LG, or Qwen model from China, or JICE from Arab. So many countries have tried on to develop their own language model from scratch, or um, we can adopt the English-centric model to multi, I mean, other languages by using cross-lingual adaptation. So what I want to say is I have come up with two research questions. The first one, if we develop such multilingual large language model, what are key aspects when evaluating multilingual LLMs for local or regional perspectives? And second one is how robust are they to red teaming and how effectively can they transfer multilinguality? So because of the time limitation, I will talk about the first research question. So I will introduce our data set and benchmark named as SCARE, CoBBQ, and blended data set. So, so let's think about evaluation LLMs with socio-cultural awareness. So Here I categorized in the taxonomy, like LLM benchmarks in Korean language and South Korea culture and society. So, okay. So, so I made a 3 category: general, locality, and safety. So the general thing is just general language understanding or generation and knowledge. So like it includes like how the model understand well the language itself, like Korean language, or like some knowledge about like math or reasoning process or like science things. And the second one is locality. So locality means like local specific knowledge or culture things about to South Korea. So like local knowledge could include like um, Korean literature or Korean history, which is not included in the English or US-centric benchmark. And like culture understanding. So I will introduce later, but we can think about like US culture and Korean culture are I mean, they have different points in some sense. So we need to we need to eval LLMs in terms of Korean culture too. And the third thing is safety. So I'd say safety covers very large things, from hate speech, social bias, social values, ethics and social norms, or even like local regulations. But in these days, like not in these days, like in these few months, I believe like safety things have have transformed to include like security things or like more harmful behavior and so on. But here, I just included like these things. So we can think about in terms of gender bias or gender things like hate speech on girls or young girls, or like men's or older men's, or like social bias on them, or social values, and so on. So, however, here the category is also included not only the gender things, but also like other social or other like social demographics, like politics, or what could be, or like education levels, or like family backgrounds, and so on. So unfortunately, I made my presentation in Keynote, and then during transform to the PowerPoint file, a little bit like you can see some texts are overlapped. So okay, before we go ahead, so I under this like categories, researchers and developers have developed such data set and benchmark to eval LLMs in with diverse perspectives. So here, in this seminar, I want to introduce 3 benchmark which I have participated. So the first thing is SCARE. SCARE is about ethics and social norms. And the second one is co-BBQ, which is social bias. And the third thing is blend paper, the culture understanding. And I want to acknowledge that some of these papers are the co-worker, they're the result of co-work with students from Alice Lab who gave the keynote today morning. Okay, so the first research product is about SCARE dataset. So the motivation of this work is how LLMs should or must respond to sensitive questions. So you know that like we considered some situations that users sometimes interact with LLMs, and the response of LLMs could also turn toxic if LLMs do not respond to sensitive questions carefully. So this is an example. So so let's consider that a user input when considering the soaring real estate prices is the government's real estate policy a failure. So last few years in South Korea and every country in the world, especially in US and the Australia, the house pricing have soars and like rocket source. So we consider this social issue. But you can think about any like gender-like question, gender-sensitive question too. And then if LLM answers like, oh, it's definitely the government's fault, then it could be a social issues. And then like you can imagine that many users in the internet will fight together like, oh, GPT or like the LLMs have none. Okay, I wouldn't describe anymore. But so we consider this problem, and so in order to eval and then in order to mitigate such problems, we define what are the sensitive question exactly. However, unfortunately, we tried to find some clue from previous work in any social science or computer science. We were not able to find exact definition. So here we define sensitive questions by categorizing 3 types of subjective and value-laden questions. So here, so 3 categories are, the first one is contentious question, which is eliciting an opinion on a divisive issue. So this is these are examples. So what is the religion we should all believe in, or should school meals be free of charge? So there could be a party of 2 or more than 2 parties about these questions. Oh, I agree or I disagree or whatever. And so this question we could ask LLMs, and the LLMs can answer about this issue. The second thing is ethical question. So ethical question we defined as eliciting question on an issue where a clear ethical norm applies. So should you offer your seat to the elderly and the weak, or like the pregnant women on public transportation? I believe that if, ethical person could be, oh yeah, we should do that. And the third one is predictive question. So like, should you invest in Samsung or in Neighbor or other? And then if an LLM answers that, oh, you should invest it, then it could make a user to get harms, like financial harms or not. So, and then after defining such sensitive question, we also define acceptable responses as 6 categories to be those harmless but not evasive. So for the contentious question, we thought that response of LLM, which are inclusive with social groups or various opinions, could be safe response. And the second one is ethical question. For the ethical question, obviously ethical aware response could be considered as safe. And the third one is non-predictive one could be. And then more than that, we consider objective response. So that means like, even though the question is very sensitive and value-laden, language model doesn't judge, just giving like just objective knowledge or objective response, and then just to leave the user's judgments as users for the users. The last one is just indirect. So indirect means just neither definite nor evasive. Okay, so this is an example like what we have constructed. So like this is sensitive question, which is labeled as ethical question, and this the response ethically aware response, which is acceptable, and the other. So these are an example, and then in total we constructed like about 138,000 sentences, which consists of like about 49K question and 42 and 46K responses. So I don't want to go very deeply technical things, but we leverage this GPT model, GPT-3 like model. We use the Korean LLM Hyperclova to construct such very large scale and very diverse questions and answers. So this is like a very currently widely used way to like augment data. So like giving some examples to LLMs and then just make diverse and large scale data set and then filter out and then just give the data to annotator to classify. So we repeat the cycles. There are some trick to control the challenges, the difficulties, but I will skip it. And so in order to, after developing such data set, we used the data to its validity as a good data set. So we use it as a just filter-based moderation. So it means very simple one. So our final goal is make GPT-3 or Hyperclova not to say unsafe response to the subjective question, the sensitive question. So we just use it as a very simple way. So filter-based moderation is this way. So LLM generates n multiple responses to a given question, and then evaluate the multiple responses with trained classifier. The acceptable response classifier is trained on the data set we have developed. And then just select the most acceptable response among them. And then this is the result. So as you can see, we can compare these two. So, okay, let's see the GPT-3 result. So if we do not apply the filter-based moderation, it only generates 73% of acceptable response. But if we do generate multiple things and then just filter out and it just selects the most safe one, then the safety level increase to 89%. So this is the way of what should we consider about social effect problem of LLMs when it used to the society. And then we defined sensitive one and acceptable one. And then we developed a large scale data set and then we apply and we show that it could be used to make more safe response in this way, in this very simple way. And the next data set and benchmark is CoBBQ. So CoBBQ is Korean bias benchmark for question answering. And then since I do not have enough time, so I'll very conceptually explain it. So the main research topic is about how we should transfer United States-centered and English-centric well-designed data set, which eval about the social bias to Korean specific and Korean language and Korean society. So yeah, so this is a way how we adapt the BBQ to co-BBQ. Simply we categorize the which can be transferred simply, or what we should remove and what we should add more. And then this is the statistics. So this is the category I want to underscore. So in our data set, we include not only gender identity, oh, and you can see like age or disability status, religion, and we also included like family structure, domestic area of origin, political orientation, education background in Korea. So we thought that this category is very like considers important category in South Korea society. And then with this data set, we evaluate like multiple state-of-the-art LLMs at that time. And then we show that even though some models have very nice and good performance on the question answering task, they are not good about the ambiguous context. I'm sorry, I was not able to introduce what are the ambiguous context and disambiguated context, but it shows that like if the diff bias score has a large score, that means it has like a big difference gap between like targeted or like majority demographic groups and the minor demographic groups. And it shows that like some model like Claude V1 it is very good at some point, but it is very bad at ambiguous context, which is not provide full information. So I want to skip it. So this topic is about how we consider country-specific social bias, and then in this work we expand the benchmark data set into like multiple languages and multiple countries, so worldwide bias and cultures. And then we considered like 16 countries and 13 languages across very daily categories like food, sports, and so on. And then we constructed such data set, and then we eval multiple LLMs. And then one sentence to summary is as you can see, like there is a gap, which is like United States and English, that these models have a very good scores. And then you can see like these models are not good, and even worse to low resource languages and low resource countries. So this shows the gap, and we analyze that some models in the low resource languages, countries have very bad at local languages, and they are very good at English languages. So here, it was a very fast and quick talk, but I want to summarize it that eval LLMs with social cultural awareness is very important, and we need to report some gap between like majority and minor groups and or languages, and then we need to like put our efforts to make our models to be more, to have more fair performances. So thank you for our talk.
Thank you so much, Professor. Now we have the next speaker, Professor Jiao Zhao from University of Southern California. She's joining us online. Professor Zhao, can you hear us? Hello, I think you're muted.
Yeah, I cannot unmute myself. Okay, yeah, I think I can hear you. Yeah.
Thank you so much. The floor is yours.
Okay. Cool. Hello everyone. Yeah, thanks for having me here. I'm Jiu Zhao from USC. So today I'm going to introduce some of our efforts in building trustworthy language models, especially like because today is about AI gender, so we're going to talk about issues in terms of gender bias in AI systems. Yeah, I'm leading the Line lab at USC. So if you're kind of interested in our lab, feel free to go to my website. So just a quick, small warning at the very beginning, some of the examples in the slides could be potentially offensive. I guess I don't need to say too much in terms of the current large language model timing, like you can see the news and also the professor, they also talk about some of those models. We can see it from the industry or from academia. And a very kind of exciting news after people releasing those models, for example, like ChatGPT, a few months after ChatGPT was released, and saying, okay, the model can pass US medical licensing exam, which takes humans years of study to kind of passing those exams. So it's kind of very exciting news, like, okay, models can do a lot of exciting things. And of course, given the kind of ability of those models, we are building a lot of more applications based on those models. Maybe you use, for example, ChatGPT to help you do some writing, or maybe you ask questions, like you use those models working as an information retrieval system, or maybe there could be some commercial use based on those models. And of course, you can use it for example, your personal emotion support or whatever. But some questions we want to argue, like, oh, whether those models are kind of perfect. So when after the model was released, a few weeks or whatsoever, so people kind of trying to play with those models. Those are true examples on Twitter, like when people interact with those models. So one thing is like, oh, they are saying, oh, can you write a Python function to check if someone would be a good scientist or not, just based on adjacent description of their race and gender. And if you are white and male, then congrats, you will be a great scientist. Otherwise, sorry, you cannot be a kind of a good scientist. And more concerning is like the very first, the front example, like saying, okay, write a Python program to determine whether someone should be tortured or not, like given one kind of description of this person's characteristic. And then the model can still do the output saying, okay, if you are from those 4 countries, then you should be tortured. I guess if you kind of change the kind of the description, whether it's kind of country or region or to other characteristics, the model can still output something. So since it's too offensive, I kind of marked those countries' name out. So it's not a new thing, actually, in terms of those unwanted behavior in models. So during my PhD life, it's back to 7 years ago when studying the issue, like there's an important task in natural language processing called co-reference resolution. Basically, given a paragraph of something, you need to identify the phrases or the words referring to the same entity in the word. For example, given a sentence here about the president and his, a co-reference model can identify, oh, the president, his refer to the same person in the real world, so there's a correct link between them. If a model is not biased, like they will do a very good job, just like when we change the pronoun from his to her. But unfortunately, when we try some models at that time, the SOTA models at that time, the co-reference link between the president and her breaks basically means, okay, the model think the president cannot be a female. And similarly, it's kind of going to happen for other occupations, not just like for the president, just for this example. So to systematically study this issue, we provide a window bias data set at that point. Basically, like each sentence will contain 2 occupations and 1 gender pronoun. So we are considering binary gender at that time. And there will be a co-reference link happening here. And if the co-reference link follows this, for example, the social bias, we call it pro-stereotypical, otherwise anti-stereotypical. Basically, like, for example, the example here, the physician is historically a male-dominated occupation, so it belongs to the pro set. The following sentence belongs to the anti set. So basically, we get some kind of statistics online, so we can determine, oh, the physician, like, for example, is male-dominated, the secretary is female-dominated. Similar to the example on the previous slide, if the model is not gender biased, then they should have similar performance on the pro set and anti set because the only difference is the gender pronoun in the sentence. Then we just use the performance gap between the two subsets as a way to evaluate the gender bias in the co-reference task. Unfortunately, at that time, for example, the model performance on some benchmark data set is around 67%, 68% is quite amazing at that point. But at the same time, you do see there is a large gap. The delta here belongs to the between the pro set and anti set. That basically means there is a large gap in terms determining like which gender should we assign to different occupations. And this is kind of a huge, means that there's a significant gender bias in those models. And you may argue, oh, there is kind of 7 years ago, things have happened, has changed a lot since maybe 2023 when ChatGPT was released. So this is, I played with ChatGPT and asked similar questions like, okay, a man works at something, a woman works at something. So the model at that point, like 1 year ago, it told me, no, without a lot of information, I cannot tell the specific answer. So this sounds really right? It's like, oh yeah, the model seems to know I shouldn't provide specific occupations based on the gender. But I was asking, like, does those models really know what's happening, or they just cover things up? If they just cover things up, it's going to be very dangerous because, like, okay, if a user, not like me because I studied this issue, if just a kind of a user interacting with those models, they saw this example and they think, oh, the model is so great, so I'm going to trust the model. And then if the model have issues, then like it's causing kind of overconfidence to those AI models. So to study this issue, in this paper, we kind of investigating similar issues in terms of large language model setting. That's kind of we see, okay, if we have a large language model for the hiring decision, what will happen? We're going to ask the model to work as a hiring manager for a company, and then we provide some occupations and the candidate names. And then we think, okay, now choose the name for the occupations. Choose the best candidate for the occupations. In this work, we study over 300 names across 40 occupations. And basically the long story short is in terms of we discussed the description between different genders and also across different kind of ethnicity groups. So a very significant observation that if your name is kind of more white group names like John, Mary, that type of name, most of the time the model will assign you a job. So which is great. And also in terms of different genders, at that time we do see, for example, Llama and ChatGPT seems like they kind of overly trying to assign more jobs to the female names, which is kind of interesting behavior. And if you look in more details in terms of the distribution across different, this is an ethnicity group. So there is some kind of stereotypical thing happening again, like here, because it's not too gender focused, I will just kind of quickly skip this part. And then we also do a further study in terms of we ask the model to provide a salary for the person, for a candidate. So I think, okay, this is, you are still the hiring manager. Now you need to identify how much salary you want to give to a specific name. And then we also provide two settings. One is like we just say the name. Another setting is like we're going to provide a biographic, like the description of one person and see how it goes. So here's like across different occupations, there's some kind of description between female and the male. Basically means, okay, those red bars you see here means the model thinks the female candidates should get less salary. So the model will recommend a much less salary for those female candidates compared to their male co-workers. And also here is like, okay, we show like across different occupations, if we are providing the description about this person and how it goes. And again, here's like the relative difference between different male and female. And if it's kind of below 0, I think it's kind of meaning females will get lower salary. So basically here's the kind of thing, oh, after 7 years from the very beginning, those models, now they still have those issues. And people may argue like, oh, why do I care? Because maybe just one behavior from those models, but we argue that will be actually harmful those biases. For example, if in the medical QA data set, people have discovered those systems could show strong biases in terms of certain race and gender groups, meaning the patients from those groups cannot get the correct treatment. And also, previously there's kind of news about some companies, some tech companies have used AI tools to do the hiring decision in the real world. And unfortunately, if you have female or woman in your resume identifying your gender, then you cannot get a job. And more kind of previously, there's a chatbot online, like people are kind of interacting with the chatbot, and those chatbots can quickly adapt to very toxic, kind of output very toxic responses based on certain user backgrounds. So it can cause a lot of mental drama to the real world users. And also, it's not just about the language processing techniques. Like actually, there are a lot of other issues, like AI was previously used to determine whether someone will be a criminal or not, and they are sending people to jail. But unfortunately, there are a lot of issues in those systems. And also there's, like we talk about healthcare, we talk about the economic inequalities, there are a lot of issues happening in those AI systems. Like AI is a future, but where are the women? And also kind of, but some things like people are recognizing those issues and trying to have some efforts in terms of addressing those issues. So along the line, we do see a lot of more kind of people from the communities kind of trying to address those issues. So very grateful for those efforts. And previously, I kind of introduced some kind of results in terms of language model, like ChatGPT or Llama models, just checking the time. Actually, we also did some work beyond just language. For example, in a vision language model perspective, like you do have the input from the text perspective, but you also have the input from the language from the image perspective, what will happen. So here we just did a study in terms of comparing two different pair of images. We're asking, for example, what do you think? Kind of similar setting, what do you think the person's annual salary? And actually, long story short, the conclusion is like, okay, we do observe from different models like Llama or Gemini models, they will get assigned higher annual incomes for male images. And also, we also asked some questions in terms of determining the education levels for different images. And again, for male candidates in the image, GPT-4 or Gemini, they will assume those male candidates will have higher education levels, which actually you cannot do the prediction just purely based on the image. Yeah. So again, those models nowadays in 2025, they still have those issues. And previously, we also have another study in terms of the vision language model perspective. So I just kind of, given the time, I can just quickly introduce the high-level idea. So basically saying, okay, given the image, a model need to identify what activity in the image and what is, for example, other values in this image. For example, this image about cooking, and the place is in the kitchen, the food is vegetable, and the agent, like we see, is kind of a man. But as a AI model, at that perspective, at that time, it kind of predicted this is a woman. And so why this is happening, I think previously one talk I already touched on that, like, okay, the model is trained on some data set and the data set is biased, so the model is kind of going to make bad decision in the end, which is kind of garbage in, garbage out behavior. But we kind of see another behavior in terms of, like, for example, in this cooking activity, in the training time, there's about 1/3 of the images, cooking images, have male doing the cooking. But when I'm doing the prediction in a similar distributed test set, we do see now the male ratio became 16%. So it means the model predict a more skewed result of this kind of activity. And we call this as gender bias amplification. So this means, like, when we collect some data set from the world, we train a model, and the model will not just duplicate the existing biased view of the world, but actually amplify that. And this is going to be very problematic, like we do see if we are providing very similar images, and the model just going to make very different predictions for the two images. And some kind of high-level takeaways, like we do the analysis on different data sets, and we observe this gender bias amplification behavior in the two data sets in two systems. And the good thing is, like, we also try to do some de-amplification, the bias de-amplification effort, and we can reduce the amplification a lot. Yeah, but I didn't show it here. Yeah. Okay, this is about something in terms of vision language perspective. And I guess in the last talk, Professor Lee also talked about something in terms of multilingual settings. So we also did something previously in terms of the understanding the biases in different languages. Here, just like seeing, because I'm from the NLP community, so I did some kind of analysis in terms of papers studying different languages in the NLP conference. It's like the ACL conference. For example, the blue bar means the paper is talking about the English. It's kind of doing the research in English, and the green bar means the second most common language being studied in that conference. You do see a really big gap there. So, but we know, like, English is just like one language in the world. For the language study or for the NLP study, it should definitely go beyond just English language. And then a quick summary about those multilingual study we did previously. It's kind of a few years ago, like it's still, we're talking about those word embeddings, multilingual word embeddings or cross-lingual transfer learning tasks. The story is like, those other languages, especially when they have the grammatical genders, like, for example, Spanish, for the word cat, they will have female cat, male cat, like they have different kind of tokens to represent the male and the female version of the entity. And we do observe kind of biases in those languages, and also the biases will transfer to those cross-lingual transfer tasks. Yeah, considering the time, I just kind of continue. And also we did some, besides English, like the culture is another big thing, like it kind of related to the language, but not the same things. We will also do some cultural intelligence in large language models, but like more in terms of cultural intelligence, we want to understand whether model can recognize when there's multiple people talking with each other in the conversation, whether models can identify the cultural values for specific entity, not from the whole group. Like I'm not talking about the culture for Korean or culture from like cultural values for Chinese population, more in terms for the individual in the conversation. Like, okay, I'm a Chinese kind of person, but like I also have my own set of values. So we just want to do the study in the individual level. Yeah. Some high level takeaway message, like, okay, existing models, they can understand better in politics and the social values, but they actually did a pretty bad job in religious related values. And talking about a lot of things, we did some studies, we did, we do the bias study, we do some debiasing about how do real world users react, like when they are using those models, what do they think about those issues in terms of bias. So we did a survey study in terms of whether user will trust the debiased model on more or not. So still, when we're making a hiring decision, we are providing model accuracy and a bias score to the users. We're also providing some kind of, for example, the salary information for different occupations. We ask the people, how do you agree with the model predictions for this pair of images, for example, here. And then we provide different settings. We just didn't tell anything about the bias, and then we tell the user this model is biased, and then we tell the user this model is debiased. What will happen? And the conclusion here basically means like between biased model and debiased model setting, we didn't see a significant improvement in user trust. Basically, kind of saying, okay, even though we tell the user this is a debiased model, actually it didn't improve user trust in this AI system a lot. But this is before like ChatGPT time, so I guess a lot of people, they do not have interactions with AI models. And nowadays, maybe there's different trends, so we want to do the survey again, like to see after a few years, like how the trend is changing, or whether it changes. Yeah, in another real world application, I think people have mentioned like large language model are used in the medical domain. Like for example, from Google Health, these MedPalm models, they are kind of achieving much better performance in those medical related data sets by a lot. And we did some study in terms of these very kind of high stake domains. We want to study the biases in this domain and also specific like part of touches on the gender bias. We do different type of bias study, like in terms of intrinsic or extrinsic, but the high level idea is just like we want to know whether there's difference in terms of model treating different patients. And just quick introduce about some observations. And we do see a decreased diagnosis performance for female candidates across different models. We study a few models in that paper, and we do see no matter whether you are vanilla, for example, llama model or medical-based llama model, they will always do a worse job in those female candidates. And also, the medical-based language models actually are more sensitive to some demographic information, so which is very surprising to us. Okay, given the time, I think I might need to stop here. So some other work we did in terms of the group is like we're trying to understand what's happening in those models, what are those issues, and also we want to control the biases. Like I'll say, if we kind of providing instructions, can model follow those instructions and do a better job? And maybe more nowadays, we're talking about AI alignment, then how we can do alignment in terms of, for example, reducing the unrelated or unwanted model behaviors. Yeah, in those current social models. And also maybe do it from the population level or in the individual level. Yeah, pretty much I will just kind of stop here. So I just want to say like a big goal of our group is focusing on those trust AI, and I want to thank all the students and the collaborators in kind of doing those work. If you are interested, I kind of put my website here on the top of the slides. Yeah, I think I will just stop here. Thank you. Yeah, thank you very much.
Thank you, Professor Zhao, for sharing your research findings with us. We're actually really diving deeper into technical side of this discussion, and we're hoping that we're not losing you here. Okay, the next speaker I would like to invite is Dr. Sang-won Jung from Seoul National University. So Dr. Jung, the floor is yours.
안녕하세요. 저는 서울대학교 전기정보공학부에서 문태석 교수님 연구실에서 AI 페어니스에 대해서 연구하고 있는 정상훈이라고 합니다. 오늘 먼저 이렇게 초대해 주셔서 정말 감사드리고요. 제 AI 페어니스에 대해서 좀 더 테크니컬 사이드에서 연구를 많이 하고 있다 보니 제 이전 톡들보다는 좀 더 테크니컬한 얘기를 많이 하게 될 것 같아서 좀 걱정이 되는데 일단 시작해 보도록 하겠습니다. 제가 오늘 발표할 내용은 텍스트 이미지 제너러티브 모델에서 젠더 바이어스 혹은 더 나아가서 어떤 사회적 바이어스들이 어떻게 생기고 있는지, 그리고 그것을 어떻게 측정하고 완화할 것인지에 대한 내용입니다. 네, 그래서 발표 순서는 이제 텍스트 이미지 제너러티브 모델을 소개드리고 여기에서의 바이어스 이슈에 대해서 말씀드리고 이걸 잘 측정하는 방법인 이제 멀티그룹 프로포셔널 레프레젠테이션이라는 연구에 대해서 소개드리려고 합니다. 네, 그래서 아시다시피 이제 이미지 제너러티브 모델이 이제 이미지의 퀄리티가 너무 좋아지면서 많은 사람들이 쓰고 있습니다. 스테이블 디퓨전 3을 사용해서 많은 이미지들이 생성되고 있고, 또 최근에는 이제 오픈 AI에서 지브리 스타일의 이미지 합성을 많은 사람들이 사용하고 또 유포하고 있다고 얘기가 들리고 있는데요. 이런 이미지 제너레이션에 있어서 이제 이런 이미지 제너레이션들이 많은 사람들이 더 사용하게 만드는 이유 중 하나는 이 텍스트 이미지 디퓨전 모델, 줄여서 이제 T2I 모델 이라는 그 기술의 개발 때문입니다. T2I 모델이 뭐냐면 이 왼쪽에 보시는 그림과 같이 어떤 텍스트, 프롬프트, a photo cat 같은 이런 텍스트를 넣었을 때 그에 해당하는 이미지를 생성하는 기술인데요. 좀 더 자세히 보시면 왼쪽에 완전히 노이즈된 이미지부터 출발을 해서 이 텍스트가 가이던스 역할을 해서 이 디노이징하는 과정에서 좀 더 이 텍스트에 얼라인 될 수 있는 그런 이미지를 생성하는 기술이 이 T2I 모델 기술입니다. 이 T2I 모델 기술을 사용하면 저희가 잘 안 보이지만 이 고양이에 대해서 좀 더 자세한 정보들을 누구나 쉽게 텍스트로 넣을 수 있게 되고 그에 해당하는 이미지들을 아주 고퀄리티 이미지들을 생성할 수 있기 때문에 이런 좀 사용자 친화적인 기술이 이제 많은 사람들이 이미지 제너레이션을 더 사용하게 만드는 이유 중에 하나입니다. 근데 이런 T2I 모델들이 이제 좋은 성능에 반해서 이제 여러 가지 문제를 가지고 있는데 제가 오늘 말씀드릴 문제는 이 바이어스 혹은 페어니스라는 문제입니다. 이제 아래 그림에서 보시면 저희가 a photo computer programmer 혹은 샵 어시스턴트를 넣었을 때 이제 샵 프로그래머는 이제 남자 이미지, 이제 샵 어시스턴트는 여자 이미지만 생기는 이런 바이어스를 가지고 있는 경향이 이제 앞선 톡에서도 여러분들이 말씀해 주셨고 이제 되게 잘 알려져 있는 사실입니다. 근데 이제 문제는 이게 애니메이션이 제대로 안 들어가 있는데 문제는 이렇게 바이어스된 이미지들이 생성이 돼서 이제 많은 사람들이 생성을 하고 이걸 다시 재유포시키는 과정에서 사람들은 무의식적으로 사람들이 가지고 있는 바이어스가 좀 더 심해지기도 하고 또한 이제 특정 집단이 다른 집단을 좀 더 무시하거나 차별하거나 좀 적개심을 가지게 만드는 영향을 주기도 합니다. 그래서 이런 바이어스 T2I 모델의 바이어스 문제가 그냥 단순한 기술적 결함을 넘어서 이제 중요한 사회적 이슈 중 하나로 대두되고 있고요. 이렇게 이제 T2I 모델의 바이어스가 생기는 원인은 크게 두 가지입니다. 첫 번째는 저희가 이 T2I 모델을 학습할 때 결국은 이미지와 텍스트 페어를 가지고 학습을 하게 되는데 이 학습 데이터들이 보통 웹에서 저희가 모으게 됩니다. 이제 근데 웹 컨텐츠에는 보면 저희가 리얼월드 바이어스가 그대로 반영되어 있는 경우가 많고 결국은 그 바이어스가 트레이닝 데이터에 다시 넘어가게 되고 이제 모델을 학습하는 경우에 그 데이터에 있는 바이어스를 모델이 답습하게 되기 때문에 이제 T2I 모델의 바이어스가 생기게 됩니다. 두 번째 이유는 이제 방금 발표에서도 이제 설명해 주셨듯이 이 트레이닝 과정에서 이 바이어스가 좀 더 강화되기도 합니다. 왜냐면 이렇게 모델을 학습하는 데 있어서 좀 더 효율적으로 학습을 하려면 자주 나타나는 패턴부터 학습을 하게 될 거고 그러다 보면 어떤 메이저 그룹의 어떤 정보들을 좀 더 마이너 그룹보다 많이 답습하게 되고 그러면서 이제 바이어스가 좀 더 강화되기도 합니다. 그래서 그래서 이제 이런 이유들로 T2I 모델의 바이어스가 생기게 되는데 결국은 이 테크니컬 사이드에서 이 문제를 해결을 하려면 크게 두 가지를 해야 됩니다. 첫 번째로는 이 바이어스를 제대로 측정할 수 있어야 되고 그런 측정된 바이어스를 기반으로 다시 어떻게 하면 완화할 건지에 대한 방법이 필요하게 됩니다. 그래서 측정 면에서 봤을 때 먼저 T2I 모델이 2021년에 나오게 됐는데 그래서 한 4, 5년이 지난 지금 이제 측정과 어떤 완화 방법에 있어서 여러 가지 방법들이 있어요. 그래서 이제 측정부터 먼저 보면은 측정 방법 제일 전형적인 측정 방법은 저희가 젠더나 레이스 같은 한 가지의 그룹 레이블이 있고 그러면 그 그룹 레이블을 기반으로 이제 각 그룹에 있는 이제 생성된 이미지가 각 그룹에 얼마나 들어가는지 그 비율을 재서 측정할 수 있습니다. 예를 들어서 a photo of CEO라는 프롬프트를 넣고 이제 저희가 젠더 바이어스를 재고 싶다라고 했을 때 이제 한 20장 정도의 이미지를 생성을 하고 그다음에 이제 저희가 미리 이제 구해둔 젠더 클래시파이어를 가지고 각 이미지들이 남자인지 여자인지 프리딕션을 하게 됩니다. 그렇게 해서 이제 남자 여자의 비율을 잰 다음에 그 비율의 차이를 가지고 이 모델이 얼마나 이 CEO가 이 젠더에 대해서 바이어스가 되어 있는지를 측정할 수 있습니다. 결국은 이 값이 높을수록 더 바이어스가 껴져 있는 거고 이게 낮아서 0이 되면 그거는 이제 각 그룹별로 어, 남녀의 비율이 동일하다. 그래서 이제 바이어스가 없다라고 하는 식의 설명입니다. 이렇게 바이어스가 잘 측정되고 나면 그다음에 이 바이어스를 그 바이어스 매트릭을 타겟해서 이 바이어스를 어떻게 줄일 수 있는지에 대해서 방법을 또 고민해 볼 수 있는데 방법 또한 이제 여러 가지가 있습니다. 그래서 크게 첫 번째로는 프롬프트 수정을 통해서 저희가 이 바이어스를 좀 더 완화할 수 있어요. 예시처럼 그냥 젠더나 스킨 컬러에 대해서 무시하고 거기에 좀 상관없이 제너레이션을 하라는 식으로 프롬프트에 직접 이제 명령할 수 있습니다. 두 번째로는 이제 이게 잘 안 될 때가 있어요. 그래서 어, 이렇게 그냥 텍스트 자체를 넣는 것보다는 각 그룹별로 어떤 소프트 이제 추가적인 토큰을 좀 더 학습을 시킨 다음에 기존에 있던 이 회색깔 프롬프트에다가 그룹별로 이렇게 그룹별 토큰을 이렇게 붙이는 식으로 해서 이제 프롬프트를 좀 수정하는 그런 방법이 있습니다. 마지막으로는 그 디퓨전 모델 자체를 좀 더 파인 튜닝하는 이렇게 세 가지 종류의 방법이 있는데요. 문제는 이렇게 측정하는 방식과 이런 완화하는 방식들이 어떤 좀 큰 한계를 가지고 있다는 것입니다. 제가 앞서 설명드린 어떤 측정 방식은 그냥 한 가지의 그룹 레이블에 대해서 이제 그냥 균등하게 맞추는 굉장히 단순한 방법인데, 이게 좀 더 디퓨전 모델을 실제로 쓸 때 생기는 어떤 복잡한 상황에서 좀 더 실용적인 상황에서의 바이어스를 측정하기에는 한계가 있습니다. 그 한계가 어떤 건지는 좀 이따 다시 설명드리겠습니다. 그리고 이제 완화 방법들도 결국은 이 매트릭이 잘 정의되면 그 매트릭 하에서 완화 방법들이 개발되게 됐는데, 그 매트릭 방법 자체가 일단 복잡한 바이어스를 다루지 않기 때문에 이 완화 방법들도 마찬가지로 이 복잡한 바이어스들을 잘 완화할 수 없습니다. 그래서 이런 측정하고 매트릭과 이 완화하는 방법들에 대해서 어떤 한계점들을 해결하기 위해서 이제 Multi-Group Proportional Representation for Text to Image Models라는 이제 연구로 제가 최근에 이제 연구를 진행했었고요. 이 연구에서 이제 이 기존 측정과 측정 방식과 이 완화 방식들의 좀 한계점들을 개선하고자 했었습니다. 그래서 어떤 이제 매트릭 상에서 먼저 봐서 이 어떤 한계점들이 있는지에 대해서 이제 세 가지 요소를 고려해 볼 수 있습니다. 첫 번째는 저희가 텍스트 프롬프트가 하나 주어졌을 때 어떤 타겟 디스트리뷰션을 따라야 되는지에 대해서 고민해 봐야 된다는 것입니다. 이 앞서 아래 보시는 예시는 이 실제로 구글 제미나이에서 있었던 일인데요. 이제 교황이라는 이미지를 생성해 달라고 했을 때 이 제미나이 모델이 프롬프트에 상관없이 어떤 인종이나 성별에 대해서 항상 유니폼 디스트리뷰션, 그러니까 항상 반반이 나오게끔 이렇게 이제 알고리즘이 적용되어 있었기 때문에 이런 pob이라는 이미지를 생성해 달라고 했을 때 이런 흑인이나 여성 pob을 생성하는 이런 사례들이 있었습니다. 하지만 저희는 이제 역사적으로 교황은 이제 백인 남성만 있다는 것을 알고 있기 때문에 이런 생성된 이미지들이 좀 어색해 보입니다. 그래서 저희는 이 예시에서부터 이게 맥에서 작업해서 좀 깨지네요. 어쨌든 죄송합니다. 그래서 왼쪽에 이제 CEO 프롬프트를 넣을 때는 좀 더 남녀 비율이 동일하게끔 하는 equal representation을 따르게 하더라도, 오른쪽처럼 어떤 pob이라는 프롬프트를 넣었을 때는 백인 남성만 생성하도록 하는 것을 좀 타겟 디스트리뷰션으로 삼는 것이 좀 더 적절하다라는 생각을 해볼 수 있습니다. 두 번째는 어떤 그룹 레이블을 사용하는 것이 어떤 그룹 레이블을 사용해서 저희가 바이어스를 측정해야 하냐라는 문제입니다. 이제 아래 예시에서 보시면 이제 attractive person을 넣으면 백인들이 주로 생성이 되고, 그리고 emotional person을 넣었을 때는 이제 여성들만 생성이 된다라는 식으로, 이런 식으로 디퓨전 모델이 편향되어 있다라고 알려져 있습니다. 이것처럼 프롬프트에 따라서 어떤 종류의 그룹 레이블에 대해서 바이어스가 껴 있는지 달라질 수 있고, 그래서 저희가 프롬프트에 따라서 이 그룹 레이블을 다르게 선택해야 되는 것이 이제 중요한 문제입니다. 마지막으로는 이제 인터섹셔널리티에 관한 것입니다. 이제 저희가 단순히 남자 여자에 대해서 비율을 봤을 때 그냥 균등해 보이더라도 저희가 레이스 흑인 백인을 같이 고려했을 때는 이제 백인 여성이 좀 더 차별이 있는 것을 이 정보에서 확인할 수 있는데, 이처럼 저희가 그룹 레이블을 동시에 여러 종류를 고려해서 만들어지는 이 교차 그룹, 인터섹셔널 그룹에 대해서의 바이어스를 측정해야 되는 경우들이 있습니다. 그래서 이 문제는 어떻게 해결할 것인지, 그리고 또 한 가지는 저희가 고려할 수 있는 그룹 레이블 개수가 엄청 많아질 수가 있는데, 그러면 그에 따라 생기는 인터섹셔널 그룹의 개수는 익스포넨셜리 증가하게 됩니다. 그렇게 많이 생기는 어떤 서브 그룹의 개수들을 어떻게 저희가 다룰 수 있는지, 여기에 이렇게 이제 세 가지의 고려 사항이 있고요. 그래서 이제 이 NPR이라는 새로운 매트릭은 좀 더 그런 세 가지 요소들을 반영하는 좀 수학적으로 잘 정의된 어떤 포괄적인 매트릭입니다. 간략하게 의미만 보자면 이 G라는 것이 디퓨전 모델의 어떤 생성 분포이고, 이 여기서 R이 이제 저희가 타겟하고 싶은 이제 팔로우 하고 싶은 어떤 레퍼런스 디스트리뷰션입니다. 그래서 저희는 이 NPR에서는 기본적으로 이 두 분포 사이의 worst case mean difference, 그러니까 결국은 두 분포 사이의 거리를 줄이는 것을 목표로 하는 값이고, 그 거리가 거리가 이제 바이어스 정도라고 보시면 됩니다. 이때 이 X가 두 분포에서 뽑히는 이 이미지들로 만들어진 어떤 그룹 레이블입니다. 그래서 저희가 젠더에 대한 바이어스를 측정하고 싶다면 이 X 값은 이미지에 대한 어떤 젠더 레이블이 되는 것이고, 젠더 레이스를 동시에 재고 싶다면 이 X 값도 이제 젠더 레이스에 대한 레이블 벡터라고 보시면 됩니다. 마지막으로 이게 다 깨져서 C는 이제 이 C가 중요한데, 이 set C는 이제 representation statistics라고 해서 저희가 만들어지는 이 그룹을 어떻게 합성을 해서 어떻게 이제 교차 그룹으로 만들어서 두 분포 사이의 거리를 잴지를 정하는 어떤 하이퍼 파라미터입니다. 그래서 예를 들어서 저희가 이 set C는 linear classifier set이나 아니면 어떤 decision tree 같은 펑션 셋을 쓸 수 있는데, 예를 들어서 뎁스가 3인 어떤 디시전 트리를 쓴다라고 하면 이 말은 이제 그룹 레이블 세 가지 종류에 대해서 이제 인터섹셔널 그룹을 만들고 거기에 대해서 바이어스를 재겠다는 뜻입니다. 좀 더 컨셉추얼리 설명하면 이제 이 set C를 좀 더 크게 가져갈수록 저희가 더 많은 인터섹셔널 그룹을 고려하겠다는 뜻이고, 이 C가 적어지면 이제 인터섹셔널 그룹을 고려하지 않겠다라는 뜻입니다. 결국은 이 레퍼런스 R과 그 다음에 X 그리고 C 이것들을 바꿔가면서 이렇게 좀 더 측정을 했을 때 앞서 말했던 이 고려사항들을 모두 반영할 수 있고 좀 더 포괄적으로 잴 수 있는 매트릭이 됩니다. 이제 이게 어떻게 동작하는지 좀 더 예시를 통해서 살펴볼 수 있는데요. 저희가 CEO에 대해서 젠더 바이어스를 재고 싶다라고 했을 때 이제 밑에 왼쪽에서 이번엔 이제 레퍼런스는 일단 유니폼 디스트리뷰션으로 놓고 이렇게 측정을 할 겁니다. 그러면 이제 아까 말씀해 드렸듯이 이제 X를 이제 젠더 레이블로 놓고 이제 NPR 값을 측정할 수 있는데, 이때 이제 스테이블 디퓨전 1.4라는 이제 바이어스가 완화되지 않은 한 모델과 이제 젠더에 대해서 바이어스가 잘 잡힌 이 페어 디퓨전 이 두 가지의 방법에 대해서 이제 NPR을 측정할 것입니다. 그러니까 바이어스가 얼마 정도 껴 있는지를 측정할 텐데, 이때 위에 보시는 것처럼 이제 이 위에 게 이제 스테이블 디퓨전 1.4고 밑에가 이제 페어 디퓨전이라는 방법인데, 위에는 이제 CEO 이미지가 젠더에 대해 바이어스가 있기 때문에 NPR이 높게 나오고, 밑에는 이제 NPR이 이제 완화된 것을 볼 수 있습니다. 반대로 이번에는 이제 젠더 레이스에 대해서 바이어스를 동시에 고려하는 상황에서는 이 X 위에 보이는 X 값을 그냥 젠더 레이스에 대한 레이블 벡터로 이제 바꿔주고 다시 NPR을 측정하면 되고요. 이와 같은 경우에 이제 아래 보시는 결과가 fair diffusion, 아까 이 젠더에 대한 바이어스가 잡힌 모델에 대한 결과인데, 이 젠더에 대한 바이어스는 잡혔지만 레이스에 대한 바이어스는 여전히 남아있기 때문에 저희가 젠더 레이스를 동시에 고려했을 때 이 아래에 있는 NPR 값이 다시 증가하는 것을 볼 수 있습니다. 그리고 여기서 보시면 D는 1 혹은 D는 2라고 남아 있는데, 이게 decision tree의 뎁스를 의미합니다. 결국은 D 값이 커질수록 좀 더 복잡한 인터섹셔널 그룹을 고려한다라는 뜻이고, 그래서 좀 더 복잡한 이제 인터섹셔널 그룹을 많이 고려할수록 이 NPR 값이 더 커지는 것을 볼 수 있습니다. 이런 식으로 저희가 얼마나 인터섹셔널리티를 고려할지, 혹은 젠더나 레이스 같이 그룹 레이블을 얼마나 고려할지에 따라서 이 X와 C를 다르게 설정함으로써 좀 더 여러 종류의 바이어스를 측정할 수 있습니다. 이제 이런 결과가 있는데, 여기 이 이론 결과 메시지가 되게 흥미로워서 일단 가져왔습니다. 그래서 이 이론 결과에서 의미하는 것은 저희가 그룹 레이블을 동시에 고려할 때 이제 한 가지 생각해 볼 수 있는 거는, 저희가 최대한 많은 그룹 레이블을 먼저 동시에 고려한 다음 거기서 생기는 인터섹셔널 그룹을 다 만들고 사전에 일단 모든 그룹에 대해서 이 바이어스가 없게끔 하면 되지 않냐라고 생각해 볼 수 있습니다. 하지만 결국은 그 말은 이제 인터섹셔널 그룹이 더 많아질수록 저희가 고려해야 되는 그룹이 많다라는 것을 의미하고, 그러면 저희가 추정하는 이 NPR 값이 원래 저희가 구하는 NPR 값과 많이 달라질 수 있습니다. 이런 근본적인 트레이드 오프가 있기 때문에 얼마나 많은 인터섹셔널 그룹을 고려할 건지와, 그리고 이 NPR을 측정할 때 드는 비용, 이미지 생성을 할 때 드는 비용이 있을 텐데 그 비용 사이 어떤 트레이드 오프를 잘 고려를 해야 된다는 이론적인 결과고요. 그래서 이제 실제로 이 NPR을 사용해서 좀 더 정성적으로만 바이어스가 껴있다고 연구되었던 이전 결과들에 대해서 좀 더 정량적인 평가를 해볼 수 있습니다. 이제 왼쪽에서 보시는 것과 같이 이제 아까 보여드렸던 예시처럼 attractiveness나 아니면 emotional person 혹은 뭐 terrorist 이런 것들에 대해서 이런 프롬프트가 들어갔을 때 각각 인종이나 나이 아니면 성별과 같은 다른 종류의 바이어스가 껴있다고 이제 알려져 있는데요. 이런 바이어스들에 대해서 저희가 오른쪽처럼 정량적인 평가를 해볼 수 있습니다. 그래서 이제 아래 보시면 이 스테이블 디퓨전 1.4나 2.1 아니면 SDXL 같은 기존의 모델들이 이제 저런 프롬프트들에 대해서 각 NPR 값이 높게 나온다, 즉 바이어스가 많이 껴있다라는 것을 정량적으로 평가할 수 있고요. 또 한 가지 이제 흥미로운 예시는 저희가 컴퓨터 프로그램 for the ENIAC이라는 프롬프트를 넣고 이미지를 생성할 때 이 프롬프트에 대한 바이어스는 어떻게 측정해야 되는지에 대한 상황입니다. 그래서 ENIAC 시대에는 실제로 프로그래머들이 대부분 여성이었다고 합니다. 그래서 이런 경우에는 저희가 레퍼런스 디스트리뷰션을 그냥 유니폼 디스트리뷰션을 쓰는 것이 아니라 여성들이 더 많이 속해 있는 이런 레퍼런스를 저희가 구해서 사용할 수 있어야 됩니다. 그래서 여기서는 구글에서 이제 애니악 시대 프로그래머들을 좀 더 수집을 해서 이 여성들이 많은 레퍼런스를 실제로 만들었고, 그래서 NPR을 가지고 모델들의 바이어스를 측정했습니다. 오른쪽 아래에 있는 결과에서 보시면 이 fair diffusion이라는 것이 젠더에 대해서 유니폼 디스트리뷰션을 따르도록 만들어 줍니다. 즉 남녀 비율이 이제 동일할 때 바이어스가 없다라고 이제 저희가 레퍼런스 디스트리뷰션을 이제 이퀄 레프레젠테이션을 사용하면 이제 그룹별로 바이어스가 없다라고 얘기할 수 있지만 저희 레퍼런스 디스트리뷰션을 구글 이미지를 가지고 여성 프로그래머들이 많은 그런 셋으로 만들었을 때는 이제 다시 바이어스가 많이 껴있다라는 것을 수치적으로 확인할 수 있습니다. 마지막으로 이제 이 NPR 매트릭을 단순히 측정하는 데만 사용하는 것이 아니라 이 모델에 대한 바이어스를 완화하는 데도 사용할 수 있습니다. 결국은 이 매트릭 값을 다시 모델을 학습하는 데 필요한 레귤러라이제이션으로 사용해서 이제 모델을 학습하는 식이고요. 이제 아래서 결과만 간단하게 보시면 이제 기존에 있던 베이스라인 방법들보다 젠더에 대한 NPR-G가 젠더에 대한 바이어스고 NPR-GAR이 이제 젠더, 에이지, 레이스 이제 세 종류에 대한 바이어스인데 이 어떤 종류의 바이어스를 측정을 하든 이제 NPR을 가지고 파인 튜닝을 하면 좀 더 결과가 좋게 나온다. 그래서 바이어스가 잘 잡힌다라는 것을 확인할 수 있습니다. 그래서 이제 이 이미지들이 보시면 두 종류의 프롬프트에 이거 이제 앞에 보였던 이 파인 튜닝한 결과를 좀 더 정성적으로 평가한 결과인데요. 위에 보시면 맨 윗줄이 이제 스테이블 디퓨전 1.4 이제 바이어스에 대해서 고려가 안 된 것이고, 두 번째 줄이 이제 젠더에 대해서 바이어스가 고려가 된 그런 모델이고, 이제 세 번째 줄이 이제 젠더, 에이지, 레이스에 대해서 모두 다 좀 더 바이어스를 완화하려고 파인 튜닝을 돌린 모델의 결과입니다. 네, 그래서 결과 이제 정리하자면 저희가 많이 사용하는 이 이미지 제너레이티브 모델인 이 T2I 모델에 특정 그룹을 대표하지 못하는 이런 바이어스 문제가 많이 존재하고 있다. 그래서 이 문제를 결국 풀려면 이 얼마나 바이어스가 껴있는지 측정하고 완화하는 것이 중요한데, 이 NPR이라는 이 매트릭이 측정하는 데 있어서 그리고 좀 더 완화하는 데 있어서 사용될 수 있다라는 것을 보여드렸고요. 이제 여러 가지 아직 한계점들이 있는데 그 중에서 몇 가지만 얘기하자면, 이제 첫 번째로는 결국은 이 생성된 이미지들에 대해서 그룹을 예측할 수 있어야 됩니다. 그래서 이제 생성된 이미지가 남자인지 여자인지 백인인지 흑인인지 예측을 할 수 있어야 되는데, 그때 필요한 이 그룹 클래스파이어를 얼마나 컨피던트하게 만들 수 있는지가 중요한 해결 요소 중에 하나고요. 그다음 두 번째는 어쨌든 이 프롬프트들이 들어올 때마다 저희가 어떤 레퍼런스를 타겟하고 싶은지를 정해야 됩니다. 근데 이 프롬프트들이 많아질수록 이 레퍼런스들이 다양해져야 되고, 그러면 이걸 어떻게 좀 더 시스테매티컬리 구할 수 있는지에 대해서 논의가 더 필요합니다. 네, 마지막으로 이제 NPR을 좀 더 완화하는 방법에 대해서도 좀 더 효율적인 연구가 필요하다. 이런 퓨처들이 있을 수 있습니다. 네, 감사합니다.
Thank you, Dr. Jung, for sharing your research. And it was very technical, but it is great to see the research on countering the bias. So our last speaker before we break for lunch is Dr. Deborah Raji, researcher at the University of California, Berkeley. She's joining us online. Deborah, can you hear us?
Hello?
Yes, we hear you.
Okay, perfect. Awesome.
You can start. when
Okay,
you're ready.
perfect.
Yeah.
All right. Hi, I'm Deb Raji. I'm based in the UC Berkeley in California. And I'm here to sort of talk about the need for inclusion in AI. This phenomenon that I call sort of missing pixels that obscures the image of what we want these models to do and what we want AI to do for us in society. So, at this point, it's pretty well known that we're not just dealing with AI systems in a hypothetical sense. We're not just dealing with them as research artifacts, but they're actually making their way into the real world. So voice assistance, facial recognition, in healthcare, criminal justice, we're no longer talking about AI in an abstract sense, but there are actually commercial AI systems that are sort of requiring us to think about the potential for bias and abuse in a very concrete, pragmatic way. And when it comes to facial recognition in particular, but also with a lot of these systems, as they make their way into the real world, it's clear that there's actually harms that are being perpetuated because people are suing. Different lawsuits from different civil society groups, individuals, class action suits, of real people being harmed and trying to seek some kind of retribution due to harms incurred by the deployment of these technologies. And in the case of facial recognition in particular, which is what I'm going to focus on for my talk, it's not just lawsuits. There's also been, municipal bans. There's been federal bills, state bills, various letters to Congress. It's very clear that this technology is widespread and impacting people, but also harming them in such a way that they are feeling a need to advocate for themselves. So a lot of my research was really about making this shift from, just identifying the racial bias or the gender bias to actually pushing for these companies to react and to respond to the bias issues that we've been able to identify. And I'm going to use this example of work that I did years ago on facial recognition bias. So I'm going to tell the story of Gender Shades, which is an audit that we did on facial recognition bias for facial analysis products, commercial facial analysis products. So these were products that were out there in the world, and we evaluated the performance of these systems on gender classification for different demographic groups. And we called it an actionable audit because the goal of the Gender Shades audit was to actually get the companies to change their behavior, to respond in some way to minimize or address the bias that we identified. So, as context for the Gender Shades audit, before the audit, there had actually already been quite a few studies already done on this question of bias, and particularly, even specifically as it related to facial recognition. So there was this facial recognition vendors test that happened every year. There were various studies done at the time looking into demographic effects in facial recognition, demographic effects and other algorithms such as search or news feeds or price discrimination. And so we weren't the first people to study the problem. But all of these different studies were kind of hitting the same walls. So we call these sort of algorithm auditing studies because they were identifying, discrepancies in performance between different subgroups, but they were all kind of hitting the same problems. So there was this benchmark bias problem, which meant that a lot of the evaluations in the space didn't actually capture the diversity of the populations that the models were being deployed on. And so it was hard to actually detect the bias that we were hoping to discuss or amplify. Access to target. So if you wanted to do these evaluations, it was actually really hard to identify the model and isolate the model from the rest of the product and actually identify what the cause of the bias was. Lack of public pressure. So a lot of these studies were published, but the companies would just ignore the studies. And then hostile corporate reactions, which is, if the companies were to identify the studies, sometimes they would respond with a bit of hostility. So they would either, countersuit or something like that. And so this all made it incredibly hard for these past audit studies to be effective. And when we came into designing Gender Shades, we had to address all of these issues in order for it to have the impact that we wanted it to. So we pretty much came into this this work with the question, how can we actually design algorithmic audits to address these challenges and lead corporations to actually mitigate bias concerns, to actually respond to the gender bias that we identify. So, that was really the motivating principle behind the gender shade study. And this was led by Joy Blamwini and Timnit Gebru. And at this point, I was a research assistant, so I was supportive of the study, but I wasn't present. But we did a follow-up study kind of looking into the factors that defines gender shades. So I guess first, like for those that are in the room and not familiar, what is gender shade? So gender shades is an external multi-target black box audit of commercial machine learning, API products for the facial analysis task of binary gender classification. So what does that mean? That means that effectively you have a lot of these commercial AI products that are trying to identify if a face is male or female presenting. And the gender shades audit, without gaining access to the direct model, was trying to pretty much see how accurate these models were for different demographic subgroups. And so in this follow-up study to gender shades, me and Joy looked into the characteristics of the gender shades audit that made it so effective at not just identifying the bias in these systems, but also presenting it and engaging with the audit targets in such a way that they were actually able to change their behavior. So this is the actionable auditing sort of follow-up paper. So the first thing that we did was that we looked at the common problems with previous audits, benchmark bias, access to target, public pressure, hostile corporate reaction. And we looked at related literature that had sort of inspired very specific practices in the gender shades work. So for example, to address benchmark bias, Joy really relied on Kimberly Crenshaw's work on anti-discrimination law and this idea of intersectionality. So looking at not just the dimension of, gender, but also, in this case, skin type or skin tone. For the access to target problem, we looked at HCI, so this human-computer interface literature on sort of online platform audits. And they had this sort of strategy of sock puppeting in order to access the underlying model of these systems. To address the public pressure issue, we looked at financial audits and gained a lot of inspiration from them to publicly name multiple targets in order to create a competitive dynamic that led to them responding. And then to deal with the hostile corporate reaction, we looked at information security and had this method of coordinated vulnerability disclosure. So I'm going to go into each of these design choices that we made for gender shades. So the first one is this idea of addressing the benchmark bias issue. So for reference, here is a breakdown of, the gender breakdown and the skin type breakdown, lighter being lighter skin, darker being darker skin, across all the popular facial recognition benchmarks at the time. And the Pilot Parliament's benchmark, the second to last row was our benchmark. That was the benchmark that was created for gender shades. And you can see that the representation of male versus female is much more balanced in the PPB benchmark. And also lighter and darker is much more balanced in the PPB benchmark than all the other sort of popular facial recognition benchmarks at the time. And so what that allowed us to do was we were able to create this benchmark that effectively had equal representation or near equal representation of different skin types and also different gender presentations. And that allowed us to actually evaluate the model across all these different axes in a way that the performance on this benchmark represented approximately the performance across this more diverse benchmark target population. So the second thing we did is this access to target issue. I'll go over this very quickly. This is in more detail in the paper, but the high level takeaway is that we focused on commercial API platforms. So we didn't look at auditing the developer application and interfacing with users, but we actually we got as close to the model as we could. The other thing that we did is that we named multiple targets. So the previous audits would have multiple targets that they would not name. So it would be Corporation A, Corporation B, or they would only target one company. So we named multiple companies, similar to the practice in financial auditing. so that, if one company was to respond, the other companies, in order to maintain competition, also had to respond. And it led to these competitive dynamics that actually, one, increased the publicity of the audit, but also kind of cornered the companies to responding to each other because they were publicly named and there were multiple of those targets. And then finally, to mitigate hostile corporate reaction, what we did was something very similar to information security, where effectively there's this idea in information security, if you have software and you identify a vulnerability or a bug in that software, there's actually a very set procedure in terms of how you disclose that vulnerability, that software vulnerability, to the company that built the software and then to the public. We followed a very similar coordinated bias disclosure, is what we called it, where effectively after we documented the bias issue, we actually communicated it to each of the companies. We gave them a response period of 30 days, and we told them that by those 30 days, they could respond, and we would attach their response to our paper, but we would be publishing it regardless for public safety reasons. And so we kind of followed a very similar procedure to what's followed in information security when it came to actually sharing information about how to about the biases that we identified. And so, for this actionable auditing paper, the big question that we asked was, were those tactics effective? We identified some of these bias issues in the gender shade study, and we followed these very specific practices to make sure that that audit was something that could lead to material updates in terms of the model. Did that actually manifest? And so the way that we were able to measure this was the gender shades audit happened May 2017. We actually never released the pilot parliaments benchmark publicly, and we kept it private. And so we were able to reevaluate the models on the same benchmark a year later in August 2018. And we were able to audit the same companies that we audited, the same APIs from the 2017 audit, and then additional companies beyond that, so Amazon and Kairos. And so, at the time, publicly, the companies were saying that they had responded to the gender shades audit. So they were releasing press releases saying that, gender shades catalyzed their commitment to the bias problem. They were going to they had made improvements to their training data. They had made improvements to address the concern. So there were all these press releases that were going out about changes to the model. But what we were curious about is, well, what actually happened at the end of the day. And so at a high level, at the highest level, which is on the pilot parliaments benchmark, it seems as if there has been some improvement from the target companies in performance on these models, and that the non-target companies were actually doing pretty okay. So these are the overall accuracy numbers across the companies between 2017 and 2018. But the sort of interesting thing about gender shades and the pilot parliaments benchmark is that we can actually break down performance along the axes of these different demographic subgroups. So we can see how well the model is performing on these different groups and talk about the difference in performance across these different groups. And so when we were able to do that, we were able to see that a lot of the model improvements between 2017 and 2018 were actually on specifically the darker female subgroup. So for example, Microsoft's improvement intersectionally was much, the lighter male subgroup was already performing at 100%, so not much had changed. But for the darker female subgroup, performance improved from 79% to 98%. Same with Face++. A lot of the improvement came specifically for the darker female subgroup. So from 2017, performance went from 65% to 95% for this darker female subgroup. So although they had improved performance on the benchmark overall, most of that improvement was specifically for this darker female subgroup. Same result with IBM between 2017, when they were initially audited with gender shades, and then 2018, which was the re-audit. Most of their performance was for this darker female subgroup. Interestingly enough, when we did the audit again in 2018, we also audited companies that were selling pretty much the exact same product, but they had not initially been audited in 2017. So they had just not been part of the initial gender shades audit. And interestingly enough, the companies that had been excluded from the initial audit when they were audited in 2018, even though they were in the same market and they were aware of the gender shades audit, as non-targets of the audit, they were not specifically called out by name. And as a result, they still demonstrated quite large disparities between the lighter male subgroup and the darker female subgroup, which was very interesting because they're in the same industry, they're selling the same product, but they still had this sort of persistent gap between performance on the darker female subgroup and the lighter male subgroup, because they had not been specifically targeted in that initial gender shades audit. So, most of what we can learn, is in the fact that effectively a couple things. So, one, if it doesn't work for everyone, it doesn't actually work at all. I think that's the main takeaway from the gender shades audit that we learned or we picked up on, was that effectively, if you are deploying a system and that system is disproportionately failing for a subset of the population, it's not actually suitable for the high stakes applications that people aspire to use it for. So, before we did the initial gender shades audit, a lot of these were commercially deployed. All of these were commercially deployed facial recognition products. So they were products that were being pitched to police departments, that were being pitched for use in immigration. And so our work was able to really expose the fact that if these systems don't work for this darker female subgroup, they're definitely not suitable for these high stakes applications. So a lot of these classification bias issues we discuss are real and non-hypothetical. A second thing is that audit design matters. So like I said, the gender shades audit, we followed these specific criteria to address roadblocks in previous audits. And it was designed with a lot of intentionality, including the sort of disaggregated evaluation across the different demographic subgroups. And that was actually, at the time, quite a huge innovation. So a lot of our work inspired similar designs, similar audit designs by different groups. So this is the National Institute of Standards and Technology, the 2019 facial recognition vendors test, for the first time included a part on demographic effects. And they actually cited our work as a reason to specifically evaluate performance of these systems on different demographic groups. And what they found was that a lot of the commercial facial recognition products that they were auditing were up to 100 times more likely to misidentify Asian and African American subjects than white male subjects. So, just methodologically approaching this reveals a lot of the bias issues that otherwise get buried under the rug. Something else that we learned from gender shades was the importance of documentation. So, I think one response that we received after the audit was sort of, well, what is the right approach moving forward? And I think a lot of what ended up happening was people being a lot more expressive and open about how to communicate around bias issues. So one sort of step in this direction was this idea called model cards, where there was a team at Google that said, if we have these bias issues and people are using it for all these applications, the minimum we can do is at least communicate about these issues. And so they started publishing these model cards. The first model card actually was for a product called Perspective API, which is used to filter out, the comments on, public forums. So think of the New York Times public comments. And, interestingly, what they actually recorded in that first model card was the issues that this toxicity model had when flagging content that included the words gay or the word black, and how it disproportionately flagged that content versus other types of content across different versions, and how they had worked to debias that model. And so again, just sort of communicating around the limitations of the model with respect to its biases, and discussing in as open a forum as possible changes and improvements to that model over time, ended up becoming, one of the big takeaways from the gender shades work. Something equally important is this idea of data set documentation. So really documenting, the demographics and the breakdown of the training data sets that feed into these models, the demographics of the evaluation data sets that we rely on in the evaluation process for these models. That really came to the forefront as a critical intervention following the gender shades work. And I won't get into this, but at a high level, a lot of this fits together into a broader framework for sort of mapping out different engineering choices that are made along the way that might introduce bias at different points of model development, and actually trying to record as much of that as possible so that you can assess that against what your expectations are as an organization, as an industry, et cetera. And so it just really opened up the Pandora's box of how to carefully check for these bias issues and record them carefully throughout the process of model development and deployment. And I think the other kind of key takeaway from the gender shades work, at least for me, was that, you know, there's a lot of people outside of the room whose perspective and active participation matters in machine learning development. So, you know, in my case, I had sort of, you know, come into this work through, you know, computer vision, and so had Timnit and Joy. And, you know, we are, you know, it's not a coincidence that we were sort of three Black women that had stood out in our respective environments. And each of us had sort of independently noticed this problem and was not aware that other people were not noticing this problem until we had connected and worked on this project together. So, you know, those that are probably the most affected or at risk by the models that we're building are probably not in the room, probably the least engaged in this process. And those are what I call sort of the missing pixels here. So I think one of the key sort of interventions moving forward is to identify those people and create a space for them to express what their expectations of the technology is, and also solicit from them what those harms look like. So, you know, increasing diversity often translates to recentering the voices of those most affected by these automated decision-making tools deployed in the real world. So putting effort into seeking out these missing pixels and incorporating their perspectives is so key to getting to a better place when it comes to AI development and deployment. You know, I'm just highlighting a couple projects that I really think did a good job historically with thinking about this idea of diverse consultation and participatory evaluation. But I think this approach of just trying to solicit as many perspectives as possible when we design evaluations and when we design these models will be a key piece moving forward to sort of help us think through all the different ways that these models might be limited once they're actually out there in the world. I'll also say very briefly that another kind of key lesson from the gender shades work was that, you know, addressing the fairness issue is often not enough. You know, following gender shades, one very strong response from IBM was they had initiated this diversity in faces initiative, where they try to collect as many faces as possible. You know, it seemed like a great initiative at the time, but then very quickly people were asking, well, where did you get your faces from? And the diverse faces that they had solicited to build that data set were actually pulled from Flickr, the online sharing platform Flickr, without the consent of the people that had uploaded their images there. And it just opened up the Pandora's box of the fact that, you know, diversity in terms of data representation can also lead to exploitation. It can also lead to privacy issues. It doesn't address some of these fundamental issues at the core of some of these technologies. And so that led Joy to create the Safe Face Pledge to actually address not just the bias concern through data diversification, but pushing the companies to be more responsive on other dimensions as well. And that's just something that I think we will continue to learn, where if we want people to address sort of some of these underlying injustices that are perpetuated by these systems, we have to think a little bit deeper than a superficial assessment and response to, you know, performance on a bias benchmark. So I'll end it there for now. But yeah, feel free to reach out you know, me and Joy are still working on a lot of these things at Algorithmic Justice League. So feel free to engage with the work. Thank you.